So, for a linear phase system, the impulse response should be symmetrical about Td. If this happens for any, if the impulse response for any system is like this, then we can say that the system is having linear phase. Next, we shall see about signal bandwidth. Signal bandwidth. So, signal bandwidth. What is a signal bandwidth? Okay, as you already know that the signals, the practical signal, any practical signal having the spectral components ranging from 0 to infinite. If it is a complex frequency means, so it has a spectral components ranging from minus infinite to plus infinite. Let us consider some x of t is there like this. So, some x of t is having some signal like this, and this has got all the frequency components ranging from 0 to infinity. Let me plot the spectrum of this signal. Let us have this spectrum is like this. Let us consider the spectrum is like this. If you carefully observe, as this is the frequency domain and this is modulus of x of omega. Let us consider this is x of omega, not modulus, this is x of omega. If you carefully observe, as the frequencies sometimes as we go on increasing, there will be components which are having less energy. Okay, if you carefully observe, some frequency components is of higher magnitude and some frequency components is having some lower magnitudes. That means we can say that some frequency components is having most of the energy and some frequency components having less energy. Okay. So, then how can we say that the signal bandwidth? As the frequencies goes on increasing, sometimes the components may reach to 0 as well. As we go on, as we tend to infinity, the x of omega may become 0. Okay. And therefore, we can say the signal bandwidth, when we will be neglecting the frequency components which is having lesser energy, that means which is having negligible energy, and we will be selecting only a band of frequencies where the 95% of the energy is concentrated. That means, for example, let us consider this is my the spectrum of some signal. So, let us consider, so these frequency components contribute 5% energy, 5%, and these frequency components contribute 95% energy, contains 95% energy. Okay. So, now I can say that this is my bandwidth. This is my bandwidth, where the 95%, all the frequency components contains 95% of the energy, and these 5% components is having negligible energy. So, this has got negligible energy. This has got negligible energy. We will select a band of frequencies where the 95% of energy is concentrated. So, that band of frequencies I am calling that as a signal bandwidth. Signal bandwidth. Okay, this can be anything. So, and remember that for any practical signal, as we go on increase, as the omega goes on increasing, the tending towards the 0 becomes more. Okay, as the frequencies becomes weaker and weaker as we increase the frequency. So, that is all about the signal bandwidth. And coming to the system bandwidth. Coming to the system bandwidth. For a distortionless transmission, we need a system with infinite bandwidth. As we already seen that for a distortionless transmission, we will be having infinite bandwidth. So, if you carefully observe, all the frequency components should undergo with the same amplification or attenuation as we go on increasing. So, but practical, there are some limitations. No physical system exists with this kind of a bandwidth. The system will respond differently, the practical systems will respond differently. So, let me give an example of a practical system which is having a bandwidth like this. Let us consider this is h of omega, this is h of omega. Remember that this we have drawn for the signal x of t, this is x of omega, and the system bandwidth we are having this h of omega, not x of omega, remember that. And this is system's frequency response, this is the system's frequency response, and this is the frequency domain representation of x of t. So, this has got some, if you carefully observe here, see the lower frequencies are getting attenuated and the higher frequencies are getting attenuated, and the frequencies that are in this range, all the frequencies in this range are undergoing with the same amplification factor. And the system bandwidth, what the system bandwidth is said to be is, it will say that the constancy of the magnitude h of omega is specified by the bandwidth. The constancy, this constancy is specified by the system bandwidth. Okay. And this constancy means all the frequencies ranging from this point to this point will undergo with the same amplification or attenuation factor. And if you want to express this constancy, and we would be expressing that in the system bandwidth. Okay. Normally, how do we take that? Here is, and this is the mid band gain h of omega, modulus of h of omega, and 1 by root 2 times, that means so what is the bandwidth is? The bandwidth of a system is defined as a range of frequencies over which the magnitude h of omega remains within 1 by root 2 times of its value at mid band. This is the value at mid band, and if this value should be 1 by root 2 times of the mid band, 1 by root 2 times of the value at mid band. This is, and this point is having 1 by root 2 times the value at the mid band, and these 2 points are nothing but called as the difference between these 2 points is nothing but called as bandwidth of the system. Let us consider this is f2, let us consider this is f1, this is upper cutoff frequency, and this is omega 1 and omega 2. This is omega 1, omega 2 is called as upper cutoff frequency, omega 1 is called as lower cutoff frequency. Okay, so if the value at the mid band is a means, and the value at this point is a by root 2. Okay, whatever be the value at the mid band, and if that is within 1 by root 2 times that of band of frequencies, I am calling that as a system bandwidth. Okay, this is a practical systems frequency response, but no system will be having the same constancy. It will the practical systems will not maintain constant for all the frequencies ranging from 0 to infinite. Practical systems will be having some limitations. Due to that limitations, we are not going to get the infinite bandwidth. Okay, that means it should respond for all the frequencies in the same way. That is not possible. This is all about the system bandwidth, and these frequencies are also known as 3 dB frequencies. 3 dB. Okay, 3 dB, lower 3 dB. So this is also 1 by root 2 means, so this is 3 dB points.